All right. Good morning. Welcome to DevOps, the first North American DevOps event here in San Jose, the San Jose Convention Center. This is my first event at the San Jose Convention Center. Usually in the Bay Area, it's the Santa Clara Convention Center where these things take place, and they're a much smaller venue. So this place is massive. It's like that projector, I suppose. I'm Tyler Jewell. I am a project lead for Eclipse Che, which is an open source project that's about 18 months old. I'm also founder and CEO of Codenvy, the originators of Eclipse Che, and we also make a Cloud IDE as well, a hosted version of that. And I'm also a venture capitalist. I'm a general partner with a company called Toba Capital, and we have about $500 million that we've invested in, and I'm an investor and board member on various developer-related businesses, some that you may have heard of, including Sauce Labs, WSO2, ShiftMobility, Cloud, which got bought by IBM a couple years ago. So it's all I've ever done. I just focus on the developer market, and I have various investment hypotheses about the segment, and those have largely played out to be true. But my day job is running Codenvy and being leader for this project called Eclipse Che. There's some background on how we came up with Che and its motivation. I tell this story. Some people laugh because I tell it pretty often, but it's relevant and true. I started off my career as a Java programmer. I worked at BEA for 6 years, and I was in evangelism, marketing, product management roles, and they were all technical. And I had a really good hands-on skills to the point where I'd written books about Java and EJBs, and was heavily involved in the advancement of the language and the WebLogic platform. And I very much enjoyed that. But then I pursued a career in management. I spent 7 years at Quest Software, rising up various levels of product management responsibility. And at one point in time, I had responsibility for about $200 million of revenue and about 30 products, 30 different SKUs, an organization, very sizable organization. And then I got sick in 2010, really ill, 9-month illness that took me offline, and it really messed with my cognitive ability. And I was really worried about my future and my outcome. And when I recovered from that illness, I just had this awakening that I wasn't necessarily enjoying this career ambitions that I had, and I wanted to reacquire some of my programming skills. And so I sat down and I'm like, oh, I miss programming in Java. So let me just get the pet store app working in Eclipse IDE. We'll get some Tomcat going. We'll do a Maven build system. And 3 days later, nothing worked. I couldn't get Eclipse to work right. Maven was foreign to me. The technology had leapfrogged me at this point in time. And so it was impossible to get these things to be configured so that all I wanted to do was compile the code, mess around with some of the Java code, see what was the advancements that were there. And it was an incredibly frustrating, humiliating, angering sort of experience for me. And I was just like, oh my God, why can't this shit just work? And it would have been easy for anybody to just give up at that point in time. And I'm sure there's lots of people who start to experiment or explore or learn about our technology, and they get to that point. It's overwhelming to them. Maybe they don't have access to a mentor or someone who's willing to coach them and walk them through it. Maybe they're not the sort of people who can sit and look at a 30-page wiki to try to figure out, follow the steps as a way to learn about a new discipline. And I was just like, look, cloud technology had come all this way. Why can't there be a link? I clicked that link, and inside that link was all the information necessary to generate the workspace that had the code inside of it, the build utilities, the runtime utilities, and a browser-based IDE that let me execute these commands so that I could get exactly into what I wanted to do. And that was the basic idea. Why can't anyone anywhere contribute to a project without having to install software first? And that was the basic idea. And we started Codenvy as a company in 2012. Prior to that, there had been this initiative called cloudide.com where we had made a very simple browser-based IDE for Java. It was very limited in what it could do, but it showed the promise and the potential of hosted runtimes and browser-based tooling sets. But we came up with this vision, and we were like, okay, how do we pursue this vision? Well, first let's break it down and talk about what's a contribution, right? And in order to make a contribution, you need three things. You need, obviously, your source code. Generally an IDE or any sort of tool, call the tool or the editor experience, whatever you want, something that you can edit with those files. But then you also need a runtime. And we historically think of the runtime as what goes into production, but the runtime here is anything necessary to run the tools that are going to lint your code, compile it, actually run it or debug it as well. So there's a whole series of things associated with that. And if you don't have that runtime, you certainly aren't going to be able to work with the code. And so that has to be available to make a contribution. Now when we install our IDE onto our desktop, we do have a runtime. It's just localhost, right? We're just installing software. And so if you're using IntelliJ or the Eclipse IDE and you say build, they're sending a Java-C command, and it's on to localhost, and there's a process there that's running there. And so it's consuming the resources of your laptop, and we just take for granted that this runtime is there. There's an operating system. We install software onto it, but it's an unmanaged runtime. And what I mean by unmanaged is that tools can install software into there. You as an individual can install software into there. You can override the customizations, and so there's no repeatability of that. And so something that works on one desktop or laptop doesn't necessarily migrate to another on that. So we need these items for contribution. A workspace is a higher order construct that historically has been seen as a wrapper around the code itself, but then provides integrations to the IDE and then also to the runtime. So that a user who's using an IDE can say load workspace 1 or load workspace 2, and there's some sort of reasonable isolation so that these workspaces can have slightly different configurations, but continue to work with the same runtime and the same IDE, right? This is traditionally how we work. But that's okay. But if you want to click on a link and magically have a workspace where you can do development, that means that the workspace has to be one that is dynamically generated, or it is portable. It's movable from one location to another. So how do we go about sharing our workspaces today? Well, one, you can do it on the IDE level where you have some sort of synchronization of your workspace config. And so if you go from one computer to another, you can take your workspace and share it. And there's a config server, and this is what the JetBrains approach. So they'll have an IDE configuration, and you can share that down. But it's just the IDE, right? It doesn't share the necessarily the configuration, and it certainly doesn't share the runtime. And if you look at OOMP, which is an open source project that's part of the Eclipse Foundation, it synchronizes not only the configuration of the workspace, but also the installation of the assets as well. So it'll install the binaries, all their dependencies, and the configuration, but again, no runtime. It assumes that it's using your localhost runtime. And Flux is another project that uses a service bus to connect two completely different IDEs that have their own independent install, and then synchronizes various assets like the files or the project tree between them. But again, just the configuration and the project code, nothing about the runtime itself, right? So how do you sync the runtime? And the runtime has all sorts of weird capabilities associated with it. There's an operating system. There's a whole series of processes, the configuration of those processes, their own dependencies on that. And something like this is not available. And this is not available because localhost has constraints, right? You can't necessarily take localhost off your desktop and just share it. You can't necessarily clone it. It's not secure, and you certainly can't scale it, right? So it's got limited RAM. It's got limited CPU. It's fixed. So the workspace that you set up using your desktop IDE is constrained by all these limits that are there. what we said with Eclipse Che was if we wanted to click a link and magically have a completely functional programming workspace, we needed to redefine the workspace. And Che takes the workspace and says, not only should it have the code and the IDE, but let's take all the dependencies, if you will, that code would require, including the runtime, and treat the runtime as a dependency, and include all of that inside of a single workspace there. And we'll redefine the definition of the workspace so that it's inclusive of all those dependencies, almost to the point where you could call it a uniworkspace, like a unikernel, right? So in Che, when we talk about a workspace is a first-class object. First thing they do is they bring their own runtimes. So every workspace has its own runtimes. These runtimes, by default, are Docker containers, but they don't have to be. They could be a VM. It could be a remote server over SSH, but it needs to be a runtime. And in the case of Che, it could be a single Docker container, like I'm just going to grab an Ubuntu or a Debian image, or it could be a Docker Compose syntax, which is a multi-container orchestration across a common shared network. So we first start and take this runtime. And this runtime could be a production runtime or something that you author yourself. So we're going to take some off-the-shelf production runtime. And then we treat the source projects as a different abstraction. So in our case, a project is a first-class object that maps to a repository. It could be a Git or a Subversion repository, maybe a zip file. But you can have one or more projects, and we are going to mount them into the workspace after the runtimes have been brought online. So we say bring up the runtime, move your projects in, and then we're going to give the projects type. It's going to be a Maven type, a C++ type, the sort of typing that you see previously, and that imbues behaviors. And then each workspace serves its own IDE. Now, these workspaces provide services, right? And we provide these services through things called agents that are running inside the workspace itself. So a standard agent could be an SSH agent, right? So a client could be a remote client and SSH into the workspace. But another agent would be an IDE agent, a workspace agent, and it's a server that's running inside the runtime. And it's got an endpoint, it's got a port, and it's a process that's running in there. And then a browser can connect to this workspace and say, give me the IDE, which is JavaScript code that it downloads. And boom, without having to install anything, as long as you know where the workspace is located, you can get the browser IDE that gives you an experience. But because there's an SSH agent, you can connect over IntelliJ or Eclipse as well, and just treat it as a desktop client against a remote workspace environment. And then the Che server is simply a server designed to host these workspaces, which have their own runtimes on that. So you can launch multiple workspaces. These workspaces could be shared among different users because they're servers now on that. And so each workspace is its own independently running self-contained entity, right? We then take for some other Eclipse technologies, particularly the JDT and Orion, and we've wrapped this up into a slightly different developer experience, one that's focused on simplifying a lot of the development experience and removing a lot of the unnecessary capabilities that exist in other IDEs. So let me just go here and bring up a demo. So is that readable? No, OK. How to zoom in? No, that's not it. Here we go. See, that didn't do it there. Made it a little bit better. So what I just wanted to show here is, we'll just maximize this. Che itself is a Docker container, right? And so you can actually say docker run eclipse/che, and it'll go and download the Docker image, and it gives you syntax there on how to run it. And so docker run eclipse/che gives you syntax, and it's a server. Right, and the syntax kind of looks complicated there, but it's simple commands. You start, you stop, you can restart the server, and there's one volume mount that's required. You've got to mount some local folder into the Docker image, and this is where your workspaces will be saved in your projects in case you bring the Che server down. But beyond that, so I'll bring up here, I've got Che running. And this is the Che server, not a workspace here. And I go to my dashboard. We'll just create a new workspace. And I'm going to create a workspace from a stack. And a stack is a way for us to describe a runtime. So the first thing I need to do is pick the runtime that's going to power my workspace. And these things, these descriptions here, ultimately just boil down to one of three things. Either a Docker file that we will compile on the fly, a Docker compose file that, again, we will execute on the fly, or a Docker image that is hosted on a registry, a private registry, a public registry. But you can pick any of those things. We have, obviously, a stack library. We could author our own if we wanted to. But I'm just going to take a default one here, which is Java MySQL. And this is a Docker compose syntax that will launch two separate containers. One for a Java Tomcat server and another for a MySQL database. And so I've selected that stack. I can then give them RAM, because these are runtimes, so you need to size them. I'm just going to take the defaults on this. One of them is going to be labeled the dev machine, which is where the IDE will connect to. The other one is more of a slave machine. That's the database machine there. And sorry, my alarm keeps going off. Like, stop. There we go. All right, and then it says, okay, what projects do you want? Now, I could just create it without a project and then clone something from Git, but we've got some templates here, and so this is a web Java project, and then project name, I'm just going to say create. And when I say create, it's going to both create the workspace and then activate it. And the bootstrap sequence of the workspace itself is to first create the workspace as an object. The second is to activate the runtime. So in this case, it's taking the Docker Compose and executing the Docker Compose service. That's creating a network. That's creating then two Docker containers. The red, that's all normal. That's all natural. After the two Docker containers are created, at least one of the containers needs what we call the workspace agent. And the workspace agent manages the health of the workspace itself. So it's how the Che server manages its relationship to the workspace, and it's how the browser ultimately gets connected to it as well. And so after the workspace runtime is completely booted, then you're going to see this next thing called starting the workspace agent. And that's going to be a Tomcat server that boots up inside of the workspace. And that then means that the workspace is completely active. And after the workspace is completely active, then the last thing is that inside the workspace, the Git utilities will then clone the source code from the repo, the sample template we chose, and it'll clone it and set it up as a project. It will define it as a Maven project, and then it will imbue the Maven capabilities. And after all that stuff is done and we verified the health checks of the workspace agent, and the projects, the IDE will be automatically loaded into the browser and available on a unique URL. So the URL at the top right now is a Che server URL. The Che server is managing this workspace in the bootstrap sequence. There it goes to create the project. And by the way, this Windows laptop, low RAM. So on if this was an Ubuntu server at DigitalOcean, this thing would be screaming right now. So, and it's Windows. So you got to forgive Microsoft a little bit. But there it goes. The project has been cloned. And you can now see on the left, the little green dot means the workspace is running. Everything's been verified. The IDE, the browser IDE is being loaded. And boom, it's done. Now this graphic is the dark experience is not all that good. Thank you. Let's try the light theme. Refresh it. See if the light theme's any better. Is that easier to read? Is that better? Yeah, okay, cool. All right, we'll just collapse the left nav bar there. And lo and behold, we've got a running workspace. And up here in the left, here's that project. We've got a project tree, and we can, in here, open files if we wanted to. Right? So we got an editor. I can, because this is a Maven project, it's actually smart enough to recognize that this is a Java package. So it's consolidated the folders. Right? If this was a C++, it wouldn't do that. And so I can see the package model. I can open up Java. One of the agents that was deployed in here, we recognize that it was a Maven project with Java. So one of the additional agents that were added was a Java language server. And the language server is a standard protocol that is about a year old now that we had done with Red Hat and Microsoft. And it standardizes the interface between an editor and IntelliSense, like autocomplete, document registration, and lookup. So I can come in here, just hit Control Space, and voila, I've got IntelliSense for Java on that. I didn't have to install anything. That was just registered as part of that. And there's all kinds of great Java IntelliSense. And there are now almost 24 of these different language servers that are out there. Python, PHP, C# is one that we support. A Clang D one is coming a little bit later this year. So these language servers are making it great and easy to just add IntelliSense without having to do any sort of special installation. You can see down here that we have two machines. So there's the database machine and the dev machine. Those are two, and they represent two containers. So these two containers are both running. They both have status. Let me just probably zoom in a little bit here on my browser. There we go. It's not how I would work, but it gets the point across. And and this is a terminal, and it's a full terminal, so I can run Midnight Commander, if that's your thing, inside of this. Let's see. We're going to go to the Maven project. There's the project we can just create. We can just touch hello, and refresh this real quick. And there's the hello, and I can say hello devox, and it's all in the cloud, so I don't have to hit save or anything like that. And more hello, and you can see that it's there. So this editor, or this terminal, is working against a file system inside the workspace. That file system is the same file system that the project tree is managing against and the files that are there, right? So I could, echo hi as an append to hello, and you can see that it added it to my editor automatically on that. Okay, all right. So let's see. I got to zoom out here. Look at that. There's a little bug there, Brad. There's the we lost the my commands. Yeah. So there's usually a toolbar here, but it looks like the light theme has lost the toolbar on the commands. So so commands are a concept, and at some point in time you need to compile your code to run your code. And a command is our abstraction for how you do that. And so commands can have type, like they could be a Maven command, they could be a bash command. And even though you define them and work on them inside the browser, the commands have to be sent to a runtime. And now you're dealing with the world of multiple runtimes here. We've got the database, we've got the dev machine, there's separate containers. So in addition to choosing the command that you want to run, you have to target it to one of the runtimes of where it should run, because they have different software installed here. And so here's a build command, and that looks really tiny, but it basically just says maven clean install and skip tests. And that's a command that's there. And if we want to, I can even the edit commands. I don't remember how to do it. Or is it on the menu, Brad? Yeah. At the edit window, like the. I don't have the. Oh. No, you can't run it here. Let's just go back to the dark preview, the dark theme. Oh, well, I'm running the nightly. It's wild. Yeah. Anyways. Well, this just gives me a good excuse to go bring up a staging server where we're rewriting the commands anyways. So we will bring up another workspace. All right, there we go. So in this version, this is a staging server. What we've done is we've got actually a command editor over here. And so here's a build command. I can open it up. It opens it up in the editor experience. And so you can see that it's maven-f. I could actually run it, believe it or not. And when I run the command, it sends it to the dev machine. And there it goes. It's off building that command. And we've got a new toolbar up here where you can see the progress of the commands, and you can choose from different commands and whatnot on it, including the debugger on that. So, and so now it's built. That project was built, and I haven't had to install anything. This concept, that workspace concept, the workspace is shareable among multiple people. The workspace itself has API endpoints, so it's programmable. You can program the workspace agent. You can program the Che server itself. And it is customizable as well. So the architecture of the way this works is, I call it a tripod. And you've got the browser, you've got the server, and you've got the workspace. And you can see that the browser is simultaneously maintaining channels of communication between the Che server and each workspace that it's connected in. So we call the Che server a master, and the master is really responsible for orchestrating the various workspaces, managing resources, because you have to limit resource consumption across all the shared workspaces. And then once the workspace is up and running, the browser and the workspace maintain a direct communication. The master itself is no longer directly engaged in the developer workflow. It's largely just there to make sure that the workspace maintains its running, and then report back to the browser if anything is broken on that. This entire architecture is completely customizable. So at the core of Che is an SDK, and with that SDK, you can create custom agents that go into the workspaces. You can create custom extensions that are packaged into the master, or you can completely change the browser IDE. And the browser IDE is actually written as a Java Google Web Toolkit, GWT, plugins on the server side, and then those plugins are compiled into cross-browser JavaScript that is then downloaded into the browser. But the architecture of this SDK for the client side is very similar to what like the Eclipse RCP platform has. So there's extensions for the editor, the panels, the menu, the buttons, all the sorts of things that you would expect. And what can happen is that when you create a custom Cloud IDE, you create extensions for the workspace, extensions for the master, extensions for the browser. You package them all together, and then they all get compiled together into a new Che Docker image, and then that Docker image you can deploy, and it will manage and set up this distributed architecture for you on that. So the whole system is completely customizable that way. And as a result, we've been able to build a bit of an ecosystem with this. We're close to 4,000 GitHub stars and about 600 forks. So it's a good project that people are forking and then trying to add either new programming languages, new types of language servers, extensions to the usability on the IDE side. You pick your poison, people are customizing it there. The activation is largely what we talked about. The first step is to start with the production runtime. It always starts off with a Docker image. This image could be cached or not. These images could be hosted at Docker Hub. It could be hosted locally. It could be hosted on a server that you set up. Or it could be just straight up Docker file syntax. And if it's straight up Docker file syntax, the Che server will use the local Docker daemon to build it, to actually take the Docker file, build it into a Docker image, and then use that Docker image from the local cache on that. Agents are packaged as zip files, and these zip files contain processes that run on the native OS. And you can adapt these for Debian, Ubuntu, CentOS, all the different flavor distributions that are out there that they can be packaged for. And a couple of agents, the workspace agent and the terminal agent, are defaults that are there because every workspace needs a terminal, every workspace needs a workspace agent. And then once the runtime is up, all the cloning, all the Git activities actually take place inside the workspace itself. So the workspace, when it does a Git clone, it comes from the workspace as if it was localhost. So once the workspace is running, it is identical to localhost. It's just running somewhere else. And so it does a Git clone, and that's how the files can come in. Once it's all set up, your IDE clients can SSH in, or we have a live workspace sync. So you can, on your local client, do a workspace sync, which will take the project files from the remote workspace and keep a two-way sync between them and a local folder. And if you do that, then you could have a local IDE using those local files, and then they're automatically pushed back up to the shared server. I'm going to skip this here. The infrastructure itself is done with Docker, of course, right? Everything, the workspaces are Dockerized containers. The actual administrative install is a Docker container, and it's actually pretty clever. So that Docker run Eclipse Che that I did at the very beginning, that is a stateless Docker container. So it will, its only job is to configure, install, start, stop, rerun other Che servers. And so, so it's a CLI bootstrap. It's a real simple syntax. It's got version management built into it. You can do an offline install if you want. So it has a way of downloading all the necessary Docker images and running Che offline. And it bootstraps things. So it verifies access to Docker. It verifies that you have access to Docker Hub if appropriate, checks the networking. And then it uses Puppet to generate a configuration. And so the CLI will actually generate custom Docker Compose syntax for your OS or however you've configured it. And then it tells Docker Compose to run that Docker Compose file, which actually runs the Che server, which is then responsible for running the workspace runtimes. So you get this container chaining. And each level of this container chaining is there to verify that you get mutability and portability of not just the workspaces, but also the Che servers, so that you can just spin them up with a single command on any different server or system. We then, sorry, that image is almost impossible to read, but we at Codenvy take Che and do a couple of things to it. So Che is a single server, single user, or shared server concept. So you can have multiple users, but they're all on a shared server. And Codenvy is a multi-server concept. So you can have as many physical servers as you want. You install Codenvy with the same exact syntax as Che, but then you just register these additional physical nodes, and Codenvy is responsible for distributing the workspaces on different physical nodes so that you can get a big workspace cluster. The second thing that we do is that we add authentication. So your users can have security, they have identity, and they have control over their workspaces. So that's permissions control. And then we have a bunch of DevOps tools for backup, recovery, administration, monitoring this. Because when you're talking about thousands of developers all sharing a same system, you're getting to run a pretty big cloud, because the average developer wants 8 to 16 gigabytes of RAM per workspace. There might be running a couple of workspaces at the same time. And so 1,000 developers turns into a pretty big architecture. And so the Codenvy architecture is that the master is there, the machines are distributed, and then we connect it with an LDAP registry, an enterprise Docker registry, and an artifact repo, and we manage it as a single system. The last thing here, and this has got a Codenvy logo on it, but we're just a couple of days away. This feature is now being ported into Che, and it's going to show up. We're now in final testing. The last thing is that original story that I started with, which is, okay, how do I get all this into a link? I just click the link and get what I want. The process that we went through was a pretty manual process. Choose your stack, choose the source code that you want to go into it, verify that the commands work, execute the command, get the browser IDE loaded up. It's not a lot of work, but it's still a couple of clicks. We have this concept called a factory URL, which allows you to take a workspace and an entire configuration and its projects of that, and then save all that configuration into a automation URL. We call it a factory. And what that factory does is that you can publish it, and when people click on that, we will execute the automation to either create or load a workspace exactly with the configuration that's there, and the user doesn't need to have any previous experience. Whoops. So can I, up here, this should have a hyperlink in it. No, of course the hyperlink's not working. So let's go to eclipse.org.che. We'll go to the SaaS variation of this. And these are all flavors of this. And I can come down here and I can choose a Spring. And when I click that, even though I'm not logged in to Codenvy, it has the encoding on that. I can just choose a Google Plus account. Choose Jewell. And so I can either create a new account or log in with it, but without having to go through that step of what do I want, that URL that was encoded with the factory has all the encoding necessary. So just by clicking on that URL, it's going to get the workspace, get the runtime, get the projects, get the commands, and then you can actually execute some macros after it loads as well, so that the end user is just plopped in and picks up exactly from where they want. And this particular example was exactly the issue that I ran into in 2010, which is the same sample app that I wanted to get working in Eclipse that I couldn't after 3 days, and roughly about 30 to 45 seconds after just clicking one link, logging in, you get everything that you wanted without having to know anything about the details of how it was set up. So you'll have to take it on me that this is loading the workspace agent, and that it'll finish for us. So let's see here. There's the sent. So our community is pretty rich. We're really fortunate to have a community that's there. Our last major release, the 5.0 release, we had 70 different contributors to it, and it's been growing. So a year ago, it was like 35 contributors to that major release. We had done 4, and we just did 5. And so it's definitely getting bigger. We're really fortunate with that. We release every 2 weeks. Our meetings are completely open on this. So we work in very tight sprints. The big features that we're focused on this year are getting Che to run natively on Kubernetes and OpenShift, because right now it runs natively on Docker. And so you'll be able to deploy Che as a pod, and then the workspaces will be also their own separate services inside of Kubernetes and OpenShift. We're going to do the same thing with Codenvy itself. We're doing a lot of work on performance. We actually think there's a lot of file system operation and management performance. There's the intelligent commands. So you saw the nice toolbar up top and command editor that's coming online. And we're doing a lot of work to simplify the customization process. We now have a new archetype generator. So there's a single command line that you run. It'll generate custom extensions and plugins. And so those are the major focuses for us this year. And then optimizing the workflow. There's lots of places where we can simplify the selection of stacks and how you get into a workspace faster. So this world is for people who want to supercharge the agile ethos. It's about, if you're moving to the cloud, it's about simplifying things for various dev teams who don't need to worry about the infrastructure or the work setup process. And that's what we designed it for. And so with that, I'll say thank you and open it up to any sort of questions that you guys may have on this. None? Okay. Yeah. What languages does it support? So the language support question is always a tricky one, and let me break it into two flavors of that. Or three flavors, really. The first flavor is editor support for syntax highlighting. There are dozens, if not hundreds. So we inherit from an Orion editor, which has fantastic globalization support and syntax for capabilities for lots. The second tier of language support is what I call the bare minimum of can I edit, compile, run, and debug on that. And in that case, you actually have access to just a lot because the stacks are completely customizable. And so because you can completely write your own Docker file for those stacks, you can set up a Swift stack that has all the Swift tools inside of it. So as long as you're comfortable doing everything on the command line, you can enable potentially any programming language within this. The third tier, which is what people really care about, is when do I get IntelliSense in the browser, the way I showed it here, and a live GUI debugger on that. Now, on the GUI debugger part, we have support for JDB, Java debugger, GDB, and a PHP Zen debugger on that. Much like I talked about the language server protocol being a generic protocol to connect editors with language servers, there's actually a matching one called the debugger server protocol that has just come online. And so over the next couple years, we should be able to see a large matching of debugger servers and a single debugger interface on that. On the language server protocol, it's fairly new, but there's already a couple dozen actual separate language servers. Right now, we have to package them one at a time. So we have to take the language server, package it as an agent, package it into this. We have instructions on how you can take an off-the-shelf language server and package it into an agent. So if you go to langserver.org, you'll see all the language servers that are available there, and they're all built by the community. We do Java, but all the others have been built by others. Hopefully, by the end of this year, knock on wood, the work is starting on what would be like a language server registry, which would allow tools like ourselves to dynamically connect, get a list of all the various language servers available for that file type, and then dynamically install it without the user having to package it as an agent or a stack on that. So depending upon the degree of you're willing to customize the system, you could have a very wide range of capabilities there. Yes, sir. Yeah.
I know the one Java language server very well.
The which one?
The one developer made up.
Yeah.
But I don't think that's the one you're using actually.
We use our own proprietary JDT.
Is this using the same protocol?
Not the same protocol, no. It's a different one for JDT. Yeah, because the Java language server is not, the actual open source Java language server is not as rich as what we do today. Yeah, yeah. Well, we'll swap it out once it crosses that threshold here. And we'd like to, anyways. The JDT version that we do, it's a memory hog. Like if you build Che and Che, the Java language server consumes 1.5 GB of memory. So like if you do Che and Che, you need like a 4 gigabyte workspace runtime, just because the Java IntelliSense just eats up half of it. All right, well, thank you. We have a booth, obviously, in the exhibit hall. We have experts there that can get you more hands-on or more detailed questions if you like. But otherwise, thank you for the session.